Heliophysics is the study of the Sun and its interactions with the Earth and the solar system. The Earth's atmosphere has 4 primary layers. The lowest is the troposphere, then the stratosphere, mesosphere, and thermosphere. These layers, particularly the upper 3 and the existence of ozone in the stratosphere, protect our planet by absorbing harmful ultraviolet radiation. NASA scientists use balloons to collect in situ measurements of the atmosphere. Sounding rockets are used to collect more detailed data in the mesosphere and the thermosphere, both of which are too high for balloons. Satellites are also used to gather measurements of the upper atmosphere. Researchers hope noctilucent cloud data will contribute to the understanding of how the Sun's cycle affects the Earth's atmosphere and pole-to-pole atmospheric circulation. Higher altitude does not necessarily mean colder temperatures, because temperature does not change consistently through the layers of the atmosphere. Temperature decreases with altitude through the troposphere, but then increases through the stratosphere. Conversely, the temperature decreases in the mesosphere, and it contains some of the coldest temperatures in the atmosphere. The thermosphere then begins to warm with higher altitude. The thermosphere warms because molecules of oxygen and nitrogen move faster at this altitude and are bombarded by radiation and energetic particles from the Sun, causing the molecules to split into their component atoms. Both the speed of the molecules and splitting of the atoms create heat. The atomic oxygen and nitrogen cannot radiate the heat from this absorption, causing the thermosphere to reach temperatures as high as 2,000 degrees Celsius. As the Earth rotates, the thermosphere is exposed to highly energetic ultraviolet and X-ray solar radiation that ionize the atomic oxygen and nitrogen in the thermosphere. These charged atoms form a layer of plasma called the ionosphere. The ionization of atoms can extend down as far as the mesosphere. However, these upper atmospheric layers are still mostly neutral, with only 1 in a million particles becoming charged daily. The density of this ionosphere layer cycles daily. At night, the ionosphere diminishes as the Sun's radiation ceases to interact with the atoms in the thermosphere. However, there are still small amounts of charged atoms caused by cosmic radiation at night. A unique property of this ionized atmospheric layer is that it reflects shortwave radio waves, enabling communication over great distances by bouncing signals off the ionosphere. However, variability of the ionosphere can disrupt communication. Solar storms is one such variable that can enhance this layer, even shutting down communication between ground stations and satellites. Solar storms can also send highly energetic particles, mostly electrons, along Earth's magnetic field lines into the upper atmosphere at the poles. Here, they interact with oxygen and nitrogen, causing formation of auroras. Auroras are formed when an energetic electron strikes an atom and one of the atom's electrons jumps to a higher energy level. When the electron returns to a lower energy level, energy is released, often in the visible light region of the electromagnetic spectrum. A deep red aurora is caused by the excitation of nitrogen atoms. Excited oxygen atoms create a green aurora at lower altitudes and a red aurora at high altitudes. A small amount of solar particles constantly precipitate from the magnetosphere, forming a background aurora that can be seen from space. NASA's AIM and Themis missions have provided valuable information about Earth's upper atmosphere. NASA's RBSP and MMS missions study the interactions at the upper atmosphere and the magnetosphere from space weather effects.
Our final journey takes us on the hunt for one of the most elusive events of the invisible world. We're attempting to find a spectacular lightning formation 50 miles wide, but so fast it's virtually invisible.
6775, transmit with you at flight level 400.
Take off your 6775.
Brief glimpses of this phenomenon have been mistaken for UFOs. They're called sprites. Like lightning, sprites are electrical discharges, but they're actually very different.
The real difference is how brief the sprites last. Normal lightning can last, if you count all the strokes together, maybe half a second. Sprites are a lot shorter in duration.
The plane's flying higher and higher, now at 50,000 feet, close to the border with space. Jupiter shines brightly in the sky.
With me flying at this altitude, it's the clarity.
It's close now. There's a storm building way below.
It looks to me like we're getting all the lightning on our backside right now, so is it possible to turn, say, 10 degrees to the left?
As the plane turns, the storm unleashes its fury. These are perfect sprite conditions. There's no time to lose.
You think we should go up, Takesh? Don't know. I don't want to hurt the intensifier.
The high-speed cameras and image intensifiers are prepared.
10,000 frames a second, 50 microsecond integration time.
They're fixed on an area just above the storm itself.
Gain is 60,500. Azimuth is 0, elevation is -4. Here we go, gang.
Trying to catch one of the most elusive phenomena in the natural world.
Sprite.
There's something.
I think it was probably outside the field of view, I'm not sure.
It could have been a sprite, but they've missed it. And the storm's about to die.
We're now at -4 degrees elevation.
Suddenly,
Sprite, we're looking. Yeah, we got it. It looks like there's two of them. What do you think you got?
a vast column of light. 20 miles tall, it dwarfs the city below. A spectacular formation, trailing globes of light. Each one is as bright as Jupiter. These high-speed images have been captured from the air for the very first time.
You and I live on seconds or minutes or maybe even years of timescales, and sprites are 1/1000th of a second. It makes you realize how different the world can be.
This vast display happens in our skies all over the world, but we're completely unaware of it. And it's thought that some reports of UFOs might instead be glimpses of these vast, super bright, round flashes. Sprites, a spectacular celestial display, a secret of the invisible world.